Hello, my name is Gracie. I'm happy to introduce my project to you today entitled Movie Lens Recommendation Overview. So my purpose is to recommend top 5 movies or top 10 movies to my user using 3 machine algorithm, which is IBCF, item-based collaborative filtering, UBCF, user-based collaborative filtering, and SVD, singular value decomposition. After applying these models, I will use some evaluator to compare the 3 models side by side. So here are the background for these models. 2 of them, IBCF and UBCF, belong to the collaborative filtering family. So the IBCF relies on the user's past preference, which is the content. And UBCF relies on similar users to my user. And SVD uses a different mechanism, which is a matrix. The matrix takes into consideration of the dependency between movies and users. So for example, Bob's preference based on his rating can be analyzed into 50% sci-fi, 30% action, and 20% classic. So we reduce these individual ratings to these percentage. So by introducing this extra layers of matrix, which combines the user and the movies, we connect them together and then reduce the raw parameters significantly. Here are the mathematics equations for all 3 models, first being item-based collaborative filtering, and second with user-based collaborative filtering. Both of them, I chose the Cosin similarity sub-methods. Third is the SVD, which is the matrix. And for the main evaluators, I use residual mean square error. Here's the formula for that. So the bigger the number, the more error, and therefore the worse performance. So moving on to dataset. I use MovieLens dataset, which is in the Recommender lab package. Here, I'm loading the needed packages. Moving on to data exploration. This data has a rating of 99,000 from 943 users, rating a total of 1664 movies. And more data exploration. Here are the first 6 lines. And here are the first 10 lines of movies with their corresponding individual ratings. And here is the first users of 3 movies. And here is the user 68 of 6 movies. And here are the total of 22 columns that this database contains. And then here I'm printing out the first 2 lines of these columns in detail, which has title, year, URL, and detailed categories of the data, etc. Moving on to data visualization. The first figure, I'm plotting out the top 10 movies based on the most watched time. So the 1977 Star Wars is the most watched movies, and here are the rest of the top 10. The second data visualization, I'm looking at the average rating by its count. It looks like it's pretty normally distributed, except a hike of 1 here. Here are the raw ratings from 0 to 5. As we can see that the rating of 0, which is missing, has terribly skewed the distribution to the left. It's easy to understand that not every user has viewed all 1664 movies, therefore give a rating. So there's a large proportion of missing here. So I decided to remove that missing, and then after the missing, replot it again, and happy to see that now the ratings are nicely normally distributed. Moving on to data preparation. I also exclude the sparse data and include the users who has rated 30 movies and more, and then the movies who has been rated 60 times and more. So that reduction and then the exclusion of 0 has practically made our database half of the size from its original. So using these data, which has 724 users and 528 movies, I applied 80% of them into training and 20% of them into testing. I chose arbitrary ratings above 3 at the cutoff point as good rating, and for each model, do 10 iterations with given of 15 items. So first model, I'm using singular value decomposition. As I can see that the run times is pretty satisfying, 1 second to 6 seconds. And the first chunk of codes is to choose this model with its details that I have mentioned before. The second chunk, after the machine learning, I use that algorithm to predict the top 10 movies for each and every single one of my user. And in this result, among the top 10 movies, I am printing out the top 4 movies for my user number 1 and number 2. So here's the user with the recommended movie title and the recommended rating. And here is for user number 2. I'm going to talk about accuracy in more detail later on. So the second algorithm I chose is item-based collaborative filtering. Again, the runtime is not a concern. And the top chunk of codes here are what I used to apply the algorithm to the data set. And then the second chunk, I'm using the algorithm that has been trained to predict the top 10 movies for each single user in the testing database. So here I am printing out all top 10 recommendations to user number 1 and user number 2. The third model I'm applying is UBCF, user-based content filtering. So the same application and the same procedure as I defined before. Here, I have applied this model to recommend top 10 movies for each and every users. Here, I'm printing out the top 4 for user number 1 and top 4 for user number 2. So in order for me to compare all these 3 models side by side, I created this list here and then do the comparison of runtime side by side. As we can see, all runtime are pretty reasonable, so that should not be a concern or hindrance for us to choose any model. Rather, we should choose our model based on its performance. And the first performance is RMSE. Here are the raw RMSE along with the MSE and MAE, which is our standard error for all 3 models. To help with the visualization, I am plotting them on this bar graph. As we can see that IBCF's standard error is way exceed the SVD and UBCF. So the item-based content filtering performs the worst in this case. And moving on to the second evaluator, receiver operative curve, which tells us the trade-off between false positive and false negative and so on and so forth, the confusion matrix. The bigger the area under curve, the better the model. The ROC curve clearly shows that SVD performs better than UBCF, which also performs better than IBCF. So IBCF is at the bottom. And the precision recall figure also tells us the same story as ROC curve. Because it's a trade-off, there's a trade-off between recall error and precision level. Looks like at any given recall error level, the SVD has a better precision level than the UBCF, than IBCF. So judging from all the performances as well as their evaluators, we conclude that singular value decomposition is the best model for us. Among the two families of collaborative filtering, user-based content filter performs better than item-based. So no wonder that all these big fan companies have heavily relied on singular value decomposition for their recommendation. Thank you and have a good day.